Alright people, welcome to another video in our MITRE tech series. So today we are going to look at system information discovery. As you can see, based on the T number, technique 1082, it's one of the older techniques. And these whole discovery topics, that's quite interesting as well. So today is Monday, the 29th of December, and let me copy these two. There we go. That's a bigger page as well. It's quite a big page. We are going to, as usual, take a look at the basics first and then dig into all the chapters that are provided by MITRE. So we are here, as the name discovery suggests, we are in the discovery phase of the kill chain. That's fairly early, so here in MITRE tech it is somewhat towards the end, but it doesn't mean that it's in the kill chain. The discovery activities happen right after you compromise the system, and now you want to know how to get further into the system. But yeah, platforms are ESXi, so that's like virtual machines that run on it. Then we have infrastructure as a service, Linux, network devices, Windows, macOS, so the operating systems. This is where discovery happens. Contributors, we have Austin Clark, we have Praetorian, so this Praetorian, let's check this out at some point. Let me mark it like this, and we will check this out at a later point. But first, let's read what they have to say here about system information discovery. An adversary may attempt to get detailed information about the operating system and hardware, including version, patches, hotfixes, service packs, and architecture. Okay, so that's what it is. So, operating systems, hardware, and including. So that's what it is first of all. And architecture. Nice. Adversaries may use this information to shape follow-up behaviors, including whether or not the adversary fully infects the target and or attempts specific actions. This behavior is distinct from local storage discovery that we will check out as the next step, I think, which is an adversary's discovery of local drive disks and or volumes. Tools such as system info, and let's mark these tools as well. As you can see, there's a link on MITRE tech on the system info, and as usual, whenever I mark something, it is a potential candidate for follow-up. But system info can be used to get a detailed system information. If running with privileged access, a breakdown of system data can be gathered through the system setup configuration tool on macOS. Adversaries may leverage a network device CLI on network device to get a detailed system information. Show version. CLI is command line interface. I was just thinking what might it mean, but yeah, it's CLI. On ESXi servers, threat actors may gather system information from various ESXi CLI utilities, again command line interface utilities, such as system hostname get and system version get. Okay, then infrastructure as a service. Cloud providers such as AWS, Google and Azure allows access. GCP, Google Cloud Computing is what it means. Access to instance and virtual machine information via APIs, programming interfaces, application programming interface. So successful authenticated API calls can return data such as the operating system platform and status of particular instance or the model view of a virtual machine. Yeah, so it is cloud and it's on-premise. That's the takeaway here where you can do discovery. And then it says system information discovery combined with information gathered from Here it's funny that it links to itself. Let me try to click that if that's really the case. Does it really just link to itself? Yes, it does. Okay, so if you click on that link here, you end up on exactly that page. So whenever we find something interesting, we need to mark it red. Okay, just again, you might want to go to MITRE and tell them, hey guys, we found something interesting here. But that's clearly just a small mistake, no big deal. It's still funny to find stuff like that. This small little distraction. But yeah, system information discovery combined with information gathered from other forms of discovery and reconnaissance can drive payload development and concealment. Yes, it can, of course. Great. Then let's go back to the editing mode. Let's copy that page here. Let's remove all of that stuff. Let's keep one of those red markers also nearby. Let's say somewhere here maybe. This. And then we want some procedure examples. And here's a ton of procedures this time. Really a lot. So we are only going to look at some of those. There are some that we have seen in the past. But yeah, let's get back to reading mode. And so here, one thing that catches my eye is this apple juice stuff. There we go, we catch that apple juice. But what do they do? So for href, that's a software. We see it by the S. We don't have a campaign here. We only have groups and softwares. So sends an OS version identifier in its beacons. Then ACID POR can identify various system locations and map devices on Linux systems as a precursor to wiping activity. Okay, then we have this admin 338. I heard that as well. It's a good name, right? You see admin, you think, if you don't pay attention, oh, it's an administrator doing real work, but no, it's a hacker. Actors use the following commands after exploiting a machine with lowball malware. We don't see lowball here, to obtain information about the OS. And this is the command. And so version in temp download, and then system info in temp download. So as you can see, these two brackets here, they mean dump the information in that folder. So it just transferred the version into the temp download, and this is a folder that is usually not so suspicious. Apparently all kinds of trash is sitting in that folder, so administrators, they tend to, or security people, they tend to think, okay, we don't have to pay attention to temporary stuff, but you have to. As you see, attackers leverage that, and this path should be added on the threat hunting list of professionals as a result of that. But yeah, so this is what does apple juice do. Let's read this last. Feel free to stop the video and carefully read what you see here. I just want to get an idea of what these guys are doing. Obviously on MITRE here you have like 100 procedures here. It's really a long page. They did a good research. But yeah, apple juice has collected the victim host information after infection. And there's a link, 22. Let's check that out. Let's go to 22. What does it say? Just to verify. Cybersecurity infrastructure. Yeah, so I wanna just copy that since I checked it out. So 22 is this one. There we go. So that's 22. Let me put it just here. Okay. So that we can just see, and then that it all makes sense. We just mark the 22 here. Alright, we mark it here and we mark it there. Now it all makes sense, I hope. Also, it should make sense if I look at it next year or so. That's the goal. In the moment of creation, everything makes sense, you know, but if I look at it next week, next year, then this will be the test, if it stands the test of time. But yeah, so let's create a copy now of this page and see what else we can find. So after the procedures, we are going to take a look at, oh sorry, I have the cough. I don't know what it is, you guys. I don't feel very healthy these days. But no worries, it's all good. So we now look at mitigations. And here it's just winter time. That's why typical flu at winter time. Nothing unusual. So okay, let's read. Let's go into reading mode and see mitigation. It says this type of attack technique cannot be easily mitigated with preventive controls, since it is based on abuse of system features. Yes, and I slowly understand the line between mitigation and detection, right? So I thought, okay, mitigate, you cannot mitigate it. You would have to turn off the system features. But of course you can create rules and prevent it. But for them, for MITRE logic, that's the detection part of it. You can argue that when you have a SOC that detects activities in real time, you can argue that this is some sort of a mitigation as well. So this is really the line between mitigation and detection is very thin. Also, if you have an EDR system that immediately puts the system in quarantine if it detects something, this can be considered mitigation too, right? But I like the way that the MITRE structures these things. For them, mitigation simply means avoid. Okay, in the risk terminologies, it would say avoid stuff by shutting it down. And yes, I totally agree. You cannot mitigate that stuff. Well, you can mitigate it in the sense of risk. Mitigation and risk means to reduce the risk. A SOC reduces risk. So that's why, try to be a little bit flexible on these terminologies here. So it says with preventive controls, and that's totally fine. Yeah, and then detection strategies. Let me see, I copied everything, yes. So they are looking out for system info, host name, WMIC, that's a Windows, I don't know what this MEIC stands. I don't know, but it's basically just a remote command line interface to your Windows machine, and then you can use I think PowerShell type of scripts. So administrators use them to manipulate the systems. That's what they do remotely. Then execution of system enumeration commands, such as, and then all kinds of commands, cat, etc, uname, df, hostname. I don't know what df is. Uname I know, uptime, hostname I know, lscpu I don't know, cat etc, OS release, well yes. Cat is just in Linux. When you use cat you can read the content of something. And it prints it out. And then execution of system utilities like system, setup, uname, sysctl. Oh yes, sysctl. I used to build use cases in the SOC for that specific, and there is more to it. So you don't just detect sysctl. This is a library of commands. It has a whole bunch of commands, and you can also monitor the use parameters and then who is executing it, and based on that you can create some interesting use cases, detection rules for your SOC. And then you have ESXi stuff. I'm not familiar with ESXi. So ESXi CLI, I never worked with it. So as a result of that, I have no clue what it is. Never executed a single command in my life by using ESXi CLI. And that just shows, okay, so I think it's okay to not be an expert in all of these things that we read here. So yes, we are familiar with security one way or the other, but please don't try to be that person that is a know-it-all. Okay, so I'm not going to Wikipedia now, reading about this and then claiming, oh yeah, I know what it is. No, no, I never used it in real life. Okay, in the job, I never had to, was never exposed to that system in the context of cybersecurity. So I know what ESXi is, but I never executed commands as an administrator. And as a result of that, if I encounter this, so if I know tomorrow I have to work with that topic, I want to implement AN 1455 in our SOC because we have ESXi and we want to catch CLI, the first thing I would do is I would find someone who is an administrator for these ESX command line interface stuff. You need an employee who is very well familiar with that stuff, and then in a corporation you build the rules. He provides you the expertise for the CLI on the ESX host, and you provide the expertise for detection scenario creation in a SOC. And this is how you get good results. Yeah, it's okay not to know it all. Then you have use of cloud API calls. Okay. And last, execution of show version, show hardware, show system. Well, that on its own is not suspicious, right? But you gotta add a little bit more context to it. Who is executing it? At what time is it being executed? And so on. So there's a lot of things that need to be taken into consideration. So here we have 508 sources. Well, that's quite the research these people did, and I really like if people go the extra mile. So nobody asks you ever to produce this many sources, but so these Praetorian people right here, or Austin Clark, C2 Defense, Merrill, and Show Hohex. So there are three people here. Not sure how to read it. So no, wait. So Austin Clark is working at Merrill Venom. Is that correct? No, Austin Clark is working at C2 Defense, and this Merrill Venom, he is working at Praetorian. Now we got it. Sometimes simple things are difficult to read. Not really, I just messed up. But what I wanted to say, these people, they deserve credit for going the extra mile on the sources here. Really, really nice to see something like that. Okay, let's see what we have here. US cert as usual. These Amazon describe instance information. Okay, that's just information about their web service, I guess. Same for Google, same for Microsoft. They just explain how their virtual stuff works. Phil Stokes, never heard of that. CrowdStrike, sure. Threat intelligence team. FireEye again. Kara Lynn, Fortinet. Buddy Tonico, Trend Micro. So you see, those are the typical EDR antivirus people that you would expect. I don't know how to pronounce that. Jua Chaco or so. To the moon and back. Lunar landing. I don't get it. What does the lunar landing? What the heck? Let's mark this down. So I'm sure. I'm sure this must have something to do with with cybersecurity. We will click on this in a moment. I'm curious. That's surprising. We always want to pick up the surprising stuff. This machete just got sharper. Oh, look, that's like a follow-up on this other hacker research that we have seen. Ehrlich et al., this name, I recognize that. And then Digital Forensic Incident Response Report. 2 of them. Okay, great. But let's take a look at this 257. What is that? And how is that even remotely? Lunar landing and deploy. Is it research provide technical likely used by the... Look at this. Look at this. So these people are doing a good job. So I was for a moment thinking they might have messed up and added some source that is just absolute irrelevant, but it's not. So we are going to mark this now, so that we know why we are here. And then I'm going to show you what this is all about. So there was indeed a hacker group targeting something that is related, and I will copy that picture too. I like it. We'll copy that picture as well. So this gives the page a little bit of character, and that's okay. And then key points of the blog post. So let's add these as well. Key points here. Right, like this. This can be a little smaller. This can be now a little bigger. And this can be, I think, on top of that. Like this. Well, let's read this. I mean, the video is now 20 minutes roughly, so we are well in time. So, to the moon and back. Let's make this, and backdoors. So they just made a little bit of a joke on the moon missions. So ESET researchers provide technical analysis of the lunar toolset likely used by the Turla APT group that infiltrated, and let's mark Turla APT as well. Let's mark that. APT is Advanced Persistent Group, and Turla I hear for the first time. The fact that they are attacking like a space agency or what is yeah, that infiltrated the European Ministry of Foreign Affairs. Oh, it has nothing to do with the moon. Just Ministry of Foreign Affairs. Okay, key points of the blog post. ESET researchers covered two previously unknown backdoors, Lunar Web and Lunar Mail, used in the compromise of a European MFA and its diplomatic missions. So the lunar toolset, it has nothing to do with the moon landing. It's just, they just called it like that. See, so it's just confusing, but now you dig a little deeper and you get what it's about. It's diplomatic missions. Lunar Web, deployed on servers, uses HTTPS for its CNC communication and mimics legitimate requests, while Lunar Mail, deployed on workstation, is persisted as an Outlook add-in and uses email messages for its CNC communications. Okay, interesting. Both backdoors employ the technique of steganography, and we learned that at university. You can't find that. So, well, you can, but it's really difficult. So steganography is like hiding a message in ASCII art, or it's like having a JPEG image and some of the colors are in such a way that you encode a message into that. Or you have an audio stream, and in that audio, every 10th second or so you have like a bit on a specific location, and you just send the audio file. Nobody knows, but the recipient knows exactly at what bit and byte to look for the hidden message. Steganography is fascinating. I had one semester dedicated to steganography. We had one lecture on that, and it was picked up every now and then, like here. It was picked up like here mentioned, but so knowing how it works is fascinating, and there are tools out there. You can just download them, steganography, JPEG, and you can say, okay, hide this message in this picture, and then you can send the picture to someone, and if that someone has the same software as you, they can decrypt the message there. But yeah, hiding commands in images to avoid detection. Yeah, and I mean, good luck detecting that. I mean, what part of the image are you going to take a look at? It's and you cannot block images probably, so that's nasty if people do that. Really nasty. But yeah, both backdoors utilize a loader that uses the DNS domain name for decryption of the payload, share portions of their code bases, and have the unusual capability of being able to execute Lua scripts. Okay. And Lua is like this general purpose scripting language, very popular. The loader can have various forms, including Trojanized open source software demonstrating the advanced techniques used by the attackers. Yeah, interesting. But okay, so I think this was a well worth to go into this one source. So it just shows how thorough and deep they do their research. Really nice. But yeah, so this is it for now. System Information Discovery T1082. So we know now where to locate it in the adversary lifecycle, in the kill chain. We have some sort of an idea what to look out for in terms of commands and on what systems to expect this. So in the cloud, ESXi, but also on the operating system itself. We have seen some procedures here. We know that mitigation is not possible, but detection is very well possible. And we have a very thorough research on this. Yeah, so far so good then. So as usual then, thank you for watching. Thank you for spending time on cybersecurity. It is time well spent. And see you in the next video then. Goodbye.